Okay, so quadratic sequences, to find the nth term of a quadratic sequence, or quadratic sequences. Now, so you understand, quadratics, or the sequence, comes in two forms. So you've got an squared plus c, which will be something like 3n squared minus 6, or you can have an squared plus bn plus c, which will be something like 3n squared plus 2n minus 7. Now, today's lesson, we're actually going to look at the top one here. So we're going to look at those there, so the an squared plus c. Now, just wait, I'll move this a little down. So I've got an example ready that I'm going to go through with some steps to hopefully help you understand. So quadratic sequence, it doesn't go up the same way like a normal linear sequence does. So to start solving this, it says here, find the first difference. So first diff. All right, so between 1 and 5, or minus 1 and 5, we get 6. Between 5 and 15, we get 10. 15, 29 is 14. And 29 and 47 is, I've got to do some maths here, is 18. Okay, so find the first difference. First step there. Okay, done. Next thing, find the second difference. Now what that means is second difference is the difference of this one you've already done there. So I'm going to do that in green there. So just right there, second diff. So between 6 and 10, we get 4. Between 10 and 14, it's 4 again. And between 14 and 18, it's also 4. All right, success. It's the same. So we've done the second difference. Now what's key here, divide second difference by 2. This is the coefficient of an squared. So an squared again, so that's 3, that's a coefficient of n squared. So it's the a we're looking for. So we take that 4 and we divide it by 2 to get 2. And that means we know our final sequence starts with 2n squared. All right, so next step, so we've got that there, we've got the coefficient. Next step, you're going to do the original sequence again, but we're going to subtract the one we just found, so that an squared sequence from it. So what we're going to do, I'm going to write that original sequence. So my hand's getting in the way. Minus 1, 5, 15, 29, and 47. So that's the original one. And they're going to write this 2n squared sequence. So the 2n squared one, so because it's 1, 2, 3, 4, 5, so 1 squared is 1, times by 2. Hopefully we can do that. So it's 2. Okay, 2 times 2, 2 squared is 4, times 2 is 8. 3 squared is 9, times 2 is 18. 4 squared is 16, times 2 is 32. And 5 squared is 25, times 2 is 50. So we've got that there. And what we're doing is we're subtracting these numbers from each other. So what we'll do, minus 1 take away 2, it's minus 3. 5 take away 8, minus 3. 15 take away 18, minus 3. And then 29 take away 32, minus 3. And 47 take away 50 is minus 3. So because it's consistent, this is what we want, because we're looking at sequences like this at the top. That means this is, our answer is the plus c on the end of the an squared. So our sequence starts with, okay, I'm going to circle this in red, it starts with 2n squared. So our final answer starts with 2n squared. And then the back part of it, because this is the same each time, minus 3 is on the end. All right, so 2n squared minus 3 is our answer. Now I've actually prepared example 2 down here. So hopefully you can still see the steps. All right, I'll do like the pause it for a moment and then I'll do the answer. Okay, kind of hoped you paused it. If you did, you did. If you didn't, you didn't. So first of all, first difference, each one, 3. Here we get 5. That difference, 7. This difference is 9. Okay, first difference. So that's our first step. Second difference now, 2, 2, 2. Okay, so we've got the second difference. So divide second difference by 2 coefficients of an squared. So 2 divided by 2 equals 1. So now our sequence starts with 1n squared. All right, just move this down a little. So we now do original sequence. So 6, 9, 14, 21, 30. And then we subtract the new sequence, so 1n squared. So 1n squared is nice and easy. 1, 4, 9, 16, 25. It's just our square numbers. Now we subtract the top, so original sequence, subtract the an squared, so our 1 squared, so our n squared, so subtract them. 6 take away 1, 5, 9 take away 4, 5, 14 take away 9, 5, 21 take away 5, take away 16 is 5, and 30 take away 25 is 5. These are all positive numbers, so we can tell it's plus 5 on the end. So our final answer is going to be n squared. We don't need the coefficient of 1. We don't need that 1 there, so it's just n squared. And then on the end, this is a positive number, so plus 5.